Alright, this is the review unit, lesson 1. We're going to go over variables and expressions. By the end of the video, we will also go over solving some simple equations. But the main things we're going to be looking over is combining like terms and simplifying our expressions. So first off, go over some terminology. A variable is just a letter that represents more than one value. It's kind of a hidden value. It's what we're trying to determine or find out. So in this equation, 3x equals 21. We need to get x alone. We're trying to find this variable x. We want to find its value. So we'd have to divide by 3 on both sides to get x alone and say that x equals 7. Same thing in this equation. We have x, again, as our variable. Now, x plus 1 equals 5, so we subtract 1 from both sides and get x equals 4. Now notice, in one case, we said that x equals 7. In another case, x equals 4. So it's just a letter that represents a hidden or unknown value. Now it doesn't always have to be 7. It doesn't always have to be 4. It can represent anything. It just represents some unknown. An expression. An expression is kind of like a mathematical statement or a sentence. It contains variables, numbers, exponents, and operation symbols, but no equal sign. When there's an equal sign, it's all of a sudden an equation. Right now, as long as there's no equal sign, these are just expressions. So 3x, this expression means 3 times some unknown value. Or how about this one, 21? It just means there are 21 of something. How about this one, x plus 1? This is saying that there's one more than our unknown value. Now all 3 of these are just statements or expressions that aren't necessarily set equal to anything. It's just kind of stating that these are here. And last term, we have like terms. Terms with the same variable parts. So they'd have the same letters and the same exponents. So 3x and x are considered like terms. They're both x terms. This one has 3 x's, this has 1 x, just the x here. On the other hand, 3x and x squared are not like terms, because this is 3 x's, this is 1 x squared. If we were to plug in a number, like let's say 2 for x, we'd have to do 3 times 2 to get this one correct. We would have to do 1 times 4 to get this one correct, because 2 squared is 4. So these would be 2's, these would be 4's, and those are not the same, so we can't combine them. So let's look over some examples. It says a car is traveling an average speed of 45 miles per hour. Write a variable expression for the distance traveled in h amount of hours. Well, if we're going 40 miles every hour, and we're going to be traveling for h number of hours, to find out our total distance, it'd be 45 times h. We can write this out as 45h. So this would be our variable expression for the distance. Now if you want, you can write it out as 45 times h, but it's easier just to write 45h. That'll account for everything. Alright, example 2. Write a variable expression for each phrase. Our first part, A. Twice the length L plus twice the width W. Well, twice the length L would be 2L plus, we'd have an add sign, twice the width W, 2W. So 2L plus 2W would be our whole expression. Now again, it never said that this was equal to anything in particular. It just said twice this length plus twice this width. So it's 2L plus 2W. Let's look at example B. The square of the number of items n times 4. Now if we had a certain number of items, and we called it n, so let's say n was like 4. There are 4 items. To square that, it would be 4 squared. Then at the end, it would be times 4. So it would be 4 times 4 squared. Now, if our number of items was a number different than 4, let's say it was like 3, then it would be 4 times 3 squared. Because we square the number of items, and then we multiply it by 4. So, if we just call the number of items n, it would be n squared, that's the square of the number of items, and then times 4. It'd be easiest to write this down as 4n squared. This 4 on the outside says we're multiplying 4 times n squared. Now again, our order of operations tells us to do exponents first. So we know whatever n is, we square it first, then we multiply by 4. And let's look at our last example here. 1 less than 3 times x. Well, whatever value x is, we would multiply it by 3 first and then take 1 less than it. So it would be 3x minus 1. 3 times x, 1 less than that amount. So 3x minus 1. All right, example 3 is asking us to simplify each expression. When we simplify expressions, we're locating our like terms and then combining them. In this expression, 10k plus 7k, this is a number of k's, this is a number of k's, 10k's and 7k's, and we're adding them together. So if we had 10k's and then we had 7k's, in total, we would actually have 17k's. So we could just call this the expression 17k. For our second example, we have n minus 7 plus 2n. Now here's a number of n's. It's kind of a hidden 1. There is one n here. Here's a number of n's. There are 2 of them. This minus 7 has nothing to do with any n's. This is what's called a constant term because it has no variables. So this minus 7 is left on its own. All of the n's in green we can combine. Positive 1 plus positive 2 becomes positive 3. So all of our n's combine to 3n. Now the only things left are our constants, the ones that don't have any variables, so we'd leave it as a minus 7 at the end. So 3n minus 7 would be this expression simplified. Let's do the same thing with this example. We have 4a minus 3 plus 5 plus 5a. This term is talking about a certain number of a's. We have 4 a's. Where else do we see anything talking about a's? Right here, this term, 5a. Now notice these are not a squared, these are just a. So these we can combine. 4a and 5a will make 9a. Other than our a values, we also have some constants. A minus 3, which you can think of as negative 3, and a plus 5, or a positive 5. Now if we combine minus 3 and plus 5, or you can think of it as positive 5 and a negative 3, those will become a negative or a positive 2. We can think of it as starting from 0, going down 3, and then back up 5. We would end up at plus 2, or positive 2. Another way to think of it is positive 5 minus 3 is still a positive 2. So in the end, this would be our expression. There are 9 a's and 2 extra constants. All right, example 4, we are now looking into solving each equation. These are just simple one-step equations to get our variable alone. In this equation, we have v minus 14 equals negative 9. We need to get v all alone. So we think, what's happening to v on this side of the equation? Well, it's subtracting 14. How do you undo subtracting 14? You would add 14 to get rid of it. If you add 14 on this side of the equal sign, I draw a line through my equal sign, I need to add 14 on the other side. Anything you do to one side of the equal sign, you have to do the other side as well. Now, a negative 14, or this minus 14, will cancel out with this plus 14. So those cancel out, and all we're left with is v on this side. So now it just says v equals. So we got rid of everything else. Now negative 9 plus 14 will come out to a positive 5. So our full equation now says v equals 5. And we can double check that by plugging it back into our equation here, taking 5 in place of v and saying 5 minus 14 equals negative 9. That is a true statement, which means that this is, in fact, our final answer. This is correct. V equals 5. Let's do the same thing for our next equation here. 8 equals negative 4a. Now again, what that means is negative 4 times a. So to get rid of that on both sides, we would divide both sides by negative 4. We do it on this side to get a alone, and we do it on this side. when we divide a negative 4a by negative 4, the negative 4's will cancel out, meaning this side is just a. So now our equation says a equals, it is positive 8 divided by negative, oops, not a negative 2, that should be a negative 4. Fix that. Positive 8 divided by negative 4 will come out to a negative 2. So in the end, our final answer is going to be negative 2. And again, we can double check by plugging it in over here. Negative 4 times negative 2 is in fact positive 8. So this one makes sense. This one is a true statement. And our last one, x divided by 16, or x over 16, equals 3. Now again, what's happening to x on our left side of the equal sign? Well, it's dividing by 16. So to undo that, we would have to multiply by 16 on both sides. When you multiply by 16 on both sides, it gets rid of this divided by 16. So now this side just says x 13 times 16, or 3 times 16 just becomes 48. And so we're now left with x equals 48. And again, we can always double check that by plugging it in and saying 48 divided by 16, what does that equal? That equals 3. This is a true statement, and this is in fact our correct answer. And that'll cover it for our first review lesson.